Okay, we're in part 6, the final part of analytical geometry, and the third example here on tangents. Okay, so determine, oh, it was so good we had it twice. Determine whether y equals x minus 5 is a tangent to the circle. Interesting, slightly different phrasing to this question now. So to be useful, right, little sketch, love the little sketches. So if we just had some sort of set of axes, I always wonder, sometimes you want to draw the axes, sometimes not. Now, this circle here, definitely going to have to put it in center radius form. So x minus 2 all squared minus 4 plus y squared equals 5. So x minus 2 squared plus y squared equals 9. So let's just jot down our centers at 2, 0. And our radius is at 3. And I'm doing that quite quickly because I think it's a fairly default thing to do is, well, where's the center? What's the radius? Well, if the center's at 2, 0, well, that's about here somewhere. The radius is 3, so it's going to go to like there and there. So I'm going to go 2, 0. I don't know, this point, might as well just work these out because they're quite easy. So this point here is at 5, 0. This point here, well, is at 3 left. So minus 1, yeah, that seems right, 0. This point, I don't know, feels too complicated to work out. I'm just filling in the bits in our sketch that are quite easy to find. Okay, so there we go. There's our circle. Now, y equals x minus 5. Now, I know that that's a positive gradient, and I know that that is going to intersect the y-axis at 0 minus 5. So the question is, does that go like that and touch it once? Does it go there and touch it twice? Or does it go over here and not touch the circle at all? Okay, well, let's draw this line. So we really need to, with circles, I find this visual thinking is so important. So let's go. If this point here is minus 5, I'd say that that's a whole lot further down here, 0 minus 5. If we worked out what the y of the x-intercept is, so this point up here, well, we know that that's 0. Well, we can work out what this value here is. It must be 5, right? 0, that fits in with our gradient. You could substitute if you wanted to. 0 equals x minus 5. Well, x must be 5 for the x-intercept. So therefore, this line is going to go through that point as well. So now be careful with our shapes now, our circles that look a little bit like eggs, like that. Okay. Now the question is, I've drawn it quite carefully, and I've drawn it quite carefully up here so that it touches twice. So I can say, no, it's definitely not a tangent. But how do I know that it didn't just touch at that point? Well, let's look at what would happen if we drew a tangent at this point over here. So I'm going to redraw my sketch here so I can just play with that idea. I don't think you need to redraw the sketch. I'm just drawing it so that I can focus in on one point. There's the center, there's 0 or 5, 0. If we drew a tangent at this point, it must be at right angles to the radius, which means that it must have gone like that. So there's no ways that this point, this line here, which is x equals 5, that's a tangent. But there's no ways that this other line over here, y equals x minus 5, is a tangent to this circle, because it definitely goes through the point 5, 0. So hopefully we're getting a sense of just looking at it, look visually at the line to go, but wait, this can't be a tangent because I can see that it's going to cut twice because the tangent would have been a vertical line. Okay, so I think that's the best way to look at that problem. Obviously, a different problem would possibly produce a different way to engage with it. And maybe you had a different way to engage with it and still could argue that it's definitely not a tangent. Okay, that was a fun example. I'll see you for the next one.